Welcome back, everybody. Today we're going to talk about exception handling and instances where you want to use exception handling and places where you want to write exception-safe code. So there's a whole school of thought where basically kind of whenever exception handling first came about, a lot of people would just wrap huge blocks of code inside of this try-catch blocks. But the problem with that is your code runs a lot slower. So instead of writing lots of code in these try-catch blocks, they generally, if necessary, you generally only wrap exactly what you think is going to fail or potentially fail inside of the try block, as opposed to a whole bunch of code that might always execute, that's always going to execute. So for example, let's go ahead and write some code that we know is going to fail, and I'll show you what I'm talking about by exception handling. Okay, let's just create a class here. Actually, let's just bring this over into here. So if we have a stream reader that we could usually use to read a file, if we point it to some file that does not exist, so we're just going to make something up, and we try to read it into a string. So let's just try to read this stuff into a string. It's going to end up throwing an exception. So it's going to compile okay because this code is perfectly valid code, but when it tries to find this file and open it up, create a stream to it, it's going to fail. So let's go ahead and take a look at that. One second here. To see my keywords there. Okay, so we're going to click this button here, it's going to throw an error for us. Okay, just took it a second. Okay, exception is file not found exception was unhandled. So basically it couldn't find the file, just exactly like we were thinking. And this is not what you want to happen in your code, because whenever someone's running your program, if something like this happens, it's potential that it's going to throw this nasty error, and they're going to either be able to click continue, and sometimes they'll be able to, it'll completely lock the program up and they'll have to just cancel out. So you never want to have those situations. Let's go ahead and stop the code here, and let's see how we could fix this. So exception handling uses this new keyword called try. Basically, it's pretty self-explanatory. It's going to try whatever's in this block of code right here, and you can have as much as you want inside of this block of code. And then, if it fails, there's a catch. There's a catch clause that's going to occur. So, let's just put a general exception there. This is the basic setup for a try-catch block. So we try this code. If everything works okay, we keep going. If it dies, then we're going to execute whatever's inside of this catch block here. So in order to run this code in this situation, it's saying that SR isn't defined because it's inside of this block. Remember, these blocks act as, they kind of bind it to, bind the variables that you create inside of this. So for example, this variable here, SR, it dies right here. It basically goes out of scope is what it's called. And it's not able to be seen right here. So what you have to do is you end up having to just declare this out here instead. So we declare that, we get rid of this declaration, and we assign to this variable a reference to this object here. Okay. So if in this situation we might want to basically, on the catch, we might want it to do something. We're not going to think of some weird thing that it's going to do, but so that's what it's going to do. Basically, there's another piece of code called a finally block, and a finally occurs no matter what. So a finally is going to happen whether or not this catch occurs, which is kind of nice because sometimes you always want a certain piece of code to happen, whether or not this up here works. So that's kind of the try-catch finally mentality of exception handling. Now there's another way to do this, and it's called exception safe code. So this is just standard exception handling. And remember, the key important thing is you only want to run this try block around small amounts of code, not huge amounts of code. You're not going to want to run it around everything under the sun, just the piece that is suspect that could potentially fail. A better way to do this example is called exception safe code. So instead of searching for this file that might not exist, what we first do is we check to see if that file exists. So we're going to grab this right here, and if the file exists, we're going to run some code. We're going to basically set up the stream reader. Oops. String s is equal to new stream reader. Oops. I can't type today. And you could pass it in whatever file. This file right here. Essentially, you'd end up running that. More than likely, these are going to be variables, but just ignore that for right now. Okay, so that would be a much cleaner solution than something like this up here, because we can check to see if it exists, and then we can do that. Otherwise, we can do something else. It runs much quicker. This try block, anytime you add these try blocks into your code, it slows the code execution down quite a bit. Could be up to a magnitude of 10, possibly. So the preferred way to do it is called exception safe code. And most of the time you can find some sort of route to check for null variables, file existing, things like that. And that will save you the hassle of having to do the other standard exception handling. Now, along with this try-catch finally example, there's something that we can do. Anytime we open up, for example, something that inherits, let's use, we can use a stream writer. Well, let's just use stream reader again. And it's not going to like this one because we have one already called that, so I'll just name it 1. So any class that inherits, so let's take a look and see what this has got here. Let's go to definition. Any class that inherits iDisposable, which this one does not, so we need to grab another one. There's this little cool using block trick that you can use, and a using block basically wraps this whole thing into some nice, much cleaner code, and it's not really a try-catch finally block, but it's a use me, and then when you're done, dispose of me, even if it dies, which is nice. Leave file. Let's see here. Give me 1 second. Okay, I found a class that inherits the iDisposable. I'll show you. So up here, this SQL connection, one of these, it's probably this one here. Yeah, this one right here inherits iDisposable. This abstract class inherits iDisposable. So that's this is one that we can use. So for example, we're making a connection to a database, and down here we do some stuff with that connection, and then before we wrap everything up, or before we end our program, we need to close that connection. If something happens in here and our program dies, then our connection never gets closed, and that's not good. That's not good to keep those database connections open, or keeping like a file handle open, etc., etc. So what the C# designers have come up with, and this is kind of what everyone does now, is anytime you have something, basically anytime you have an object that can be disposed of, so you look at dispose, then you need to set your statement up like this. So instead of doing it like that, we wrap it inside of this little using block here, just like that. So it's pretty much the same, except for we just wrap it inside of this using. And what this does is this will dispose of this connection. It'll close it and dispose of it. And if there's some sort of error that occurs, like if we were doing it inside of here, it has a finally block. It has a catch block and a finally block that actually go ahead and close that connection for you, so you don't have to worry about it being left open. So this, while this is not directly, a try-catch finally exception handling, this is used for situations where you have an object that is disposable. So use this in situations where you have objects which inherit that interface. Okay, and that's exception handling.